Welcome to solverfy.
So at first, we will find the number of moles of CO2 which was formed from the combustion of 1.5 gram of the sample. So the number of moles of CO2 will be mass over molar mass of CO2. So the mass of the CO2 which was produced is 3.52 gram. That means the number of moles will be 3.52 over the molar mass of carbon dioxide, which is 44.01 gram per mole, and this will give us a value of 0.08 mole. Now, since in one molecule of CO2 we have one atom of carbon, that means 1 mole of CO2 will have 1 mole of carbon, and 0.08 mole of CO2 will have 0.08 mole of carbon. That means the number of carbon in CO2 will also be 0.08 mole. Now from here we can find the mass of CO2, the mass of C in the CO2 produced, which will be simply the number of moles of C times the molar mass of C, which is 12.01 gram per mole, and this will give us a value of 0.96 gram. So this is the mass of C in the CO2 produced. That means this is also the mass of C in the sample of 1.5 gram. Since the carbon, so the amount of carbon in CO2 is the amount of carbon in the sample, because the complete combustion of the substance gives us this value of carbon. That means the complete combustion means that the amount of carbon in the original sample is completely combusted to give this much amount of carbon in CO2. So we can assume that this is the amount of the whole carbon which is present in the original sample. Now, since we are given the amount of chlorine in 1 gram of sample, for that reason we will find the amount of carbon in 1 gram of sample. So if 1.5 gram of sample contains 0.96 gram of carbon, 1.5 gram sample contains 0.96 gram carbon. That means 1 gram of sample will contain 0.96 gram over 1.5 gram, which will give us a value of 0.64 gram carbon. So this is the amount of carbon in 1 gram of sample. Now we'll find out the mass of chlorine in 1 gram sample. So when 1 gram of the sample is uh, converted to AgCl, or it is converted to 1.27 gram of AgCl. So to find out the mass of Cl, just following the similar process, first we will find out the number of moles of AgCl produced. So the number of moles of AgCl produced will be the mass of AgCl produced over the molar mass of AgCl, which is 143.32 gram per mole, and this will give us a value of 0.01 mole. Now again, since one molecule of HCl contains one chlorine atom, that means 1 mole of HCl will contain 1 mole of chlorine, and 0.01 mole of HCl will contain 0.01 mole of Cl. So the number of mole of chlorine will also be 0.01 mole. That means the mass of chlorine in the HCl produced will be 0.01 mole times the molar mass of chlorine, which is 35.45 gram per mole. It will give us a value of 0.31 gram. So this is the amount of chlorine formed or which is formed or produced in the form of AgCl. um, that means this is the amount of chlorine in the original sample of 1 gram. Now we know the amount of chlorine in 1 gram sample, and we know the amount of carbon in 1 gram sample. From that we can find the amount of hydrogen in 1 gram sample. So if we just write once again, the amount of hydrogen in 1 gram sample will be 1 gram minus the sum of the carbon, which is 0.64 gram, plus the sum of chlorine, which is 0.31 gram, and this will give us a value of 0.05 gram. So this is the mass of hydrogen in a 1 gram sample. Now we know the mass of each um, element which is present in 1 gram of a sample. Now we will find the number of moles for each element. So number of moles of carbon will be the mass of carbon in 1 gram, which is 0.64 gram, over the molar mass of carbon, which is 12.01 gram per mole, and this will give us a value of 0.05 mole. Now we will find the number of moles of hydrogen, which will be the mass of hydrogen 0.05 gram over the molar mass of hydrogen, which is 1.008 gram per mole, and it will give us a value of 0.01 mole. Oh no, it will be 0.05 mole again. And the number of moles of chlorine will be equal to the molar mass, the mass of chlorine in 1 gram, which is 0.31 gram, over the molar mass of chlorine, which is 35.45 gram per mole, and this will give us a value of 0.01 mole. Now we know the number of moles of each element present in 1 gram sample. Now we have to find out the simplest whole number ratio of these moles, and we will find that by simply uh, we'll just divide each number of moles by the smallest number of moles, which is 0.01 mole. So we'll divide each number of moles by this to get the simplest whole number ratio for each element. So the whole number ratio for carbon will be 0.05 mole over 0.01 mole, which will give us a value of 5. Then similarly, the ratio for hydrogen will be also 0.05 mole over 0.01 mole, which will also be 5. And for chlorine, it will be 0.01 mole over 0.01 mole, which will be equal to 1. So the simplest whole number ratio here will be 5 is to 5 is to 1, and that means the empirical formula for this substance will be C5H5O. So this is the empirical formula. Oh, not O, it is Cl, C5H5Cl. So this is the empirical formula for this substance.